when you shoot a reality television series, then the production team has to bring in some external excitement to make it more interesting, and time pressures and unexpected events. We don't need to do that. We have that all built in. Jon is somewhere at an airport or about to be at an airport, and he will speak right now. I've already introduced you, so I won't lose any more time. Go ahead.
Thank you very much. I am so sorry that I've botched up my time zones here. I thought I was all on top of this and clearly was not. So I think that you can see, could somebody confirm you can see the slides okay?
Good. Yes.
Okay, good. All right, so I'm gonna make this quick and efficient to tell you the story rather than spending more time apologizing for my screw up of the time zones. I'm gonna tell you a pretty interesting story about the experience we had trying to explore the possibility that maybe probability sample internet surveys, it was a dying methodology. And the starting point for this here was in 2012, this is 538.com's summary of the performance of pre-election polls. And the precursor to the USC online panel, which is our focus and interest today, in part is when it was at the RAND Corporation, was the tremendous success of this panel in this chart showing you these are organizations listed in a descending order here from the most accurate to the least accurate in predicting the outcome of the election, and in 2012 in the presidential election. And RAND did extremely well in this context. And so it was particularly surprising that 4 years later in 2016 in the New York Times, Nate Cohen said the USC Dornsife Los Angeles Times Daybreak poll has emerged as the biggest polling outlier of the presidential campaign. And in particular, this came from the fact that if you looked at an average of polls over the period from June 2015 well into 2016, Hillary Clinton, represented by the blue line, was leading Donald Trump in the popular vote consistently across this time period. And yet, if you look at the bottom line in this figure, that this is the pre-election measurement of the lead and of the two candidates. And this bottom line, because it's below the solid line in the middle here, is indicating that the percent of votes measured by this poll that had been so successful in 2012 was very much out of step with the others and had Donald Trump leading the popular vote. And in fact, in the post-election wrap-up, in an article in the Los Angeles Times noted the fact that the tracking poll was not perfect. It projected Trump to win the popular vote by slightly over 3 percentage points. And as you may know, one possible explanation for what appeared to be the difference between the two sets of data, mostly RDD data on the one hand with human interviewers versus the online self-administered probability sample, was social desirability, and in particular the Scheid-Trump hypothesis. Now, I'll skip that for a moment, but just to say that in the end, of course, this line here shows you the proportion of popular vote that went to Hillary Clinton. This line shows you the proportion of the popular vote that went to Donald Trump. And these are all RDD polls over to the right, which show you the proper outcome, Clinton being predicted to win more votes than Trump and being close. This is the USC prediction that's in the opposite direction, that has Trump predicted to win the popular vote. And so we know, since the RDD surveys involve human interviewers, that Scheid-Trump hypothesis can't be right, because they were not distorted substantially in that way. Another possible explanation, though, has to do with underrepresentation of hard-to-reach groups. And this is what Nate Cohen put forward in the New York Times. And I'm going to actually just skip this and focus here on the fact that he claimed that the problems for the USC poll came, first of all, from weighting using very tiny groups, such as, for example, only 18 to 20-year-old men, which is a tiny group of the population. Secondly, weighting by past vote, where he said people don't report their past vote very accurately. They tend to overreport three things: voting for the winner, and voting for some other candidate. They underreport voting for the loser. So weighting based on past vote is risky. And lastly, he pointed out that there was no trimming of weights. So there were some huge weights in the data set. And what he said was when he created more conventional weights, you can see here, this yellow line at the top is his set of predictions that are showing Clinton winning the popular vote consistently across this time period with an ending of 4 percentage points. What I'm going to propose to you today, though, is a different explanation, and I think one that has value for everybody on this call. And this has to do with unequal probability of selection during the recruitment process of the Understanding America panel, as well as suboptimal post-stratification of the people who completed the questionnaire. So let me tell you about how the Understanding America panel was recruited. It was recruited by ABS sampling, meaning that a sample of residential addresses was drawn and written invitations were mailed out. The selected addresses were selected through a process that began by randomly sampling zip codes in the country, and then randomly sampling 40 households per zip code. Now, if you think about that just for a second, what that means is that the probability of selection of a household is unequal across zip codes. And in particular, if all adults are invited in a household to join the panel, then people living in more populated zip codes have lower probabilities of selection. So for example, in zip code 59351 in Montana, there are a total of 89 housing units, which means that there's almost a 50% probability that any one housing unit will be selected. Whereas in Brooklyn, New York, there are 30,000 housing units and the selection probability is tiny. So this needs to be taken into account, and it is a process called base weighting that adjusts for unequal probabilities of selection, which is a piece of the story told by Matt DeBell and myself in this paper, which was written at the time that we were running the American National Election Studies. This is a paper available online that describes the recommendations of a blue ribbon panel of survey statisticians on how to compute weights properly for probability sample data. And the first advice they provide is that base weights need to be created to account for unequal probabilities of selection. And then post-stratification needs to be done with no more than 5 categories per variable, with a single category containing at least 5% of the population and 5% of the sample, and using only variables that have substantial differences, more than 5 percentage points from the population, and capping weights at 5 times the average weight. None of this was done with the USC sample, and what I want to show you is what happens when we actually did this. So these are 2 categories of variables that we looked at: primary demographics that are used in weighting, as well as what we'll call secondary criteria, such as health status and cigarette smoking, that can be compared between the USC panel and high quality federal high response rate surveys. And what you can see here is that using the USC original weight, the average absolute error for those variables is 2.4 percentage points, whereas with the new weight, there's a slight improvement to 2.1 percentage points. So that's a good sign. In terms of predicting accuracy, in terms of predicting turnout in the presidential election in 2016, the actual voting age population turnout rate was 54.7%. And as you can see in the first column here, no matter whether we're using unweighted data or the original USC weight or the new weight, turnout is vastly overestimated. Instead of about 55%, we're seeing almost 90% estimated turnout. But you can see that the average absolute error is the smallest using the new weight. So again, a slight improvement, but not a big deal. But here's where the big deal comes. If you look at the unweighted data, these are the candidate choice predictions made by the USC data: 46% voting for Trump, 44% voting for Clinton. This is the predicted Trump victory that's wrong, and this is the average absolute error of 3.1 percentage points. When you look at the original weight, that actually does get slightly better by 3 percentage points, but Trump is still winning. In the end, however, with the new weight, this reverses. So Clinton is now winning 46 to 44, and the average error is, again, 3 percentage points. But importantly, we've got the right winner in place. What's notable here is that this big error comes mostly from overestimating the proportion of people who said they would vote for somebody other than Trump or Clinton. And I'm going to propose to you that this has to do with the use of probability questions. What's the percent chance that you will vote in the presidential election? And if you vote in this election, what's the percent chance that you'll vote for Trump or vote for Clinton or vote for somebody else? This is asking for mathematical calculations. I know this has become standard in the health and retirement surveys. It's often used in the Understanding America panel surveys. But what I want to suggest to you is that when you look at these data, and I'm going to do this quickly, this is a bit of a speculative analysis, but if we focus only on the people who said they have a 100% chance of voting and who have a 100% chance of voting for their preferred candidate, instead of the complex weighting analysis, which takes into account the numbers less than 100%, you can see the average absolute error is now in the range of what the USC panel has typically gotten, what RDD surveys get, and it's got Clinton winning the popular vote by almost exactly the right amount. So the conclusions, first of all, optimal weighting improves accuracy of probability samples. Secondly, only the new weights yielded accurate predictions of the winner of the popular vote. Third, asking respondents to report probabilities may account for some of the remaining error. And most importantly, probability sampling is not dead, but it is critical that we not overlook base weighting, because unequal probability of selection can, and in this particular case, did make a significant difference in terms of accuracy. Thank you.
Yes, thank you very much.